Session 1 gave an overview of the need for communication buses on aircraft and described several bus architectures. Session 2 will focus on the nuts and bolts of MIL Standard 1553. In this session, we will review the goals behind the design of MIL Standard 1553 and briefly describe the mindset that led to the design decisions very different from most other buses. We will then describe the nature of the messages that are transmitted over the bus, through which we will gain an in-depth understanding of how the bus works. The designers of 1553 wanted to deal with the need for up to 32 devices on an aircraft to communicate with each other. The assumption was made that most data needed for transfer on an aircraft is short and can be fitted into a message of 32 16-bit words. A central requirement for the specification was the ability to detect errors so that the data could be resent if necessary, and the pilot could be informed if any devices were malfunctioning. I don't think it is a coincidence that MIL Standard 1553, which was designed at the request of the military, has a bus controller that maintains strict discipline over all devices on the aircraft. Civilian buses such as Ethernet, Firewire, and ARINC 429 are much more egalitarian. Most specs designed for military aircraft in the last 10 years are based on existing civilian buses and no longer have the notion of a bus controller. We will see that there are a number of message types defined within 1553. All communication on the bus is performed using one of these message types without exception. The first word of every message is a command word, and only the bus controller may transmit a command word. These strict rules guarantee that no two devices, which we'll call RTs for remote terminal, ever try to transmit at the same time. These are the different types of messages that the bus controller can initiate. Note that even an RT to RT command is initiated by the bus controller. The BC to RT command refers to the direction of the data flow and represents data being transmitted by the bus controller and received by a single RT. Now, housekeeping messages do not transmit data but are used for synchronization purposes or other functions necessary to maintain the health of the system. There are three parts to a message. The first part is always the command word transmitted by the bus controller. The order of the other two parts depends on the type of message. They are the data to be transmitted and received, and a status word, always sent by an RT to indicate successful reception of the command, and if the RT is receiving data, successful reception of the data as well. A closer look at the command word shows that it is 16 bits long and comprised of 4 distinct fields. We'll look at these fields one at a time. The first field is a 5-bit field called the RT address. Having 5 bits gives it a range of 0 to 31, allowing for up to 32 RTs in the network. Some aircraft use address 31 as a broadcast address, allowing messages to be transmitted to all RTs simultaneously. These aircraft can only support up to 31 remote terminals. The next field is a single bit denoting the direction of the data flow. A 1 in this field instructs the RT named in the first field to transmit. A 0 in this field indicates that the RT is to receive data. When broadcast is used, RT31 will never be used in combination with a 1 in the TR bit. Broadcast is only used for messages in which the bus controller transmits to all RTs. The following field within the command word is the sub-address field. Some RTs are comprised of multiple subsystems, and this field can be used within the RT to route the message to the appropriate place. A 0 or 31 in this field indicates that the message is a mode code. The final field is the word count or mode code field. For a regular message, this field indicates the number of words to be transferred. A 0 indicates 32 words are to be transferred. All non-mode messages must contain at least one data word. For mode codes, this field indicates the type of mode code. Some types of mode codes are accompanied by a single data word. All others contain no data. Let's move on to the status word, sent by the RT to indicate successful reception of a command word, or for BC to RT command, successful reception of the command and data words. The RT responds with its own address, followed by a bit indicating that an error has occurred in a previous message. The message error does not refer to an error in the current message because RTs do not send the status word if an error is detected. A service request bit is a method of the RT informing the BC that an unexpected urgent bit of information is available in the RT. The BC can use this information to change its order of command to give more priority to this RT. The broadcast bit indicates that a broadcast command has been received by this RT in a previous message. RTs do not transmit a status word in response to a broadcast command. A busy bit indicates that a request for data by the BC has been denied because the RT is unable to respond to it at this time. Here we are looking at a graphic representation of the different message types. A receive command, also called a BC to RT command, is followed immediately by the data the BC wishes to transmit. Only the RT named in the command word pays attention to this message. If the command and data are successfully received, the RT will respond with a status word. A transmit command, also called an RT to BC command, begins with a command word. The RT named in the command word has up to 8 microseconds to respond with a status word, followed by the requested data. Following each complete message, the bus controller waits at least 2 microseconds before sending the next message. An RT to RT command begins with the bus controller sending 2 command words. The first instructs an RT to prepare to receive data, and the second instructs a different RT to transmit data. The transmitter then transmits a status word, followed by the requested data. Finally, the receiving RT transmits a status word indicating successful reception of the command and data. Mode commands may contain no data or a single data word. The single word may be transmitted from the BC to an RT or from an RT to the BC. This sums up all the different message types used in MIL Standard 1553. In the next session, we'll look at some methods of creating lists of these messages that prioritize messages according to the critical time of the data. If you have any questions or comments, you may find our contact information on our website at www.mil-1553.com. Thank you.